All right. Welcome, everyone. We're excited to be hosting the 10th GraphQL meetup here at Twitter. I think this is the third that we're hosting, so that is exciting. So my name is Haggai, and I'm an engineer on the Core API team here at Twitter. My team is responsible for operating the GraphQL service, among many others, and we also hold the vision and strategy for our internal APIs here at Twitter. Um, as Josh mentioned, I'm going to be talking to you about automating schema generation today. That is my handle on Twitter. You could follow if you like. Um, so, kind of like to give you an agenda of what I'm going to be talking about. Um, sort of like talk to you about the challenges of introducing GraphQL at a company the size of Twitter. And then we're sort of going to look at Twitter's architecture and discuss sort of like some of the trade-offs and benefits of that architecture. Then we're quickly going to explore how you might build a simple GraphQL schema on that. And we're then going to look how we can actually automate generating that schema. And even though we won't be actually building a real-time schema generator, the hope is that this sort of gives you an idea of how you'd go about it, implementing it yourself. Yeah, all right, let's get to it. All right, just a quick shout. I think last week, Twitter officially joined the GraphQL Foundation, and we're really excited for this opportunity. Looking forward to learn and share some of the things that we've learned running GraphQL in the past 2 years. So essentially, among many other things, you can expect to hear more about GraphQL from Twitter, conferences, meetups like this one, and we'll also be blogging about it. We're also a heavy Scala shop at Twitter, so our backend is entirely in Scala, almost. And that means that we use Sangria to power our GraphQL servers. And we're also looking forward to sort of like working with that and supporting the community where we can, and also learning. All right. Before we go, just sort of like a quick survey. Hands up if you consider yourself a backend or server engineer. Okay, thanks. Client-side engineer. Okay, I kind of see like some full stacks in there. Hands up if you're using GraphQL in any way, side projects at work. Okay, thanks. Running it in production at work. Okay, that's a lot. All right, thanks. Let's get going. All right, so Twitter is famously a microservice company. I'm not going to go much into details here, but as you might already know, Twitter was originally built on the Ruby monorail, and moving to this architecture has allowed us to scale both technically and as an organization. But it also presented us with some challenges regards to rapid prototyping and feature development. Services are often coming up and going down, and this might be surprising, but it's actually hard to know how many services are running in production at any time. And a quick estimate told me there's 2,000 services at the moment. So we have HTTP services, and these are the ones we expose to the outside world. And then we also have thrift services, and these are the majority of the services that we run. And these are private on our internal network. And the only way to sort of like get your hands on one of them is to expose it as an HTTP service or through an HTTP service. And each of these services are exposed in an asynchronously typed interface. And this means that all communication between our microservices is already typed. It's not GraphQL type, but it's types nonetheless. And at the very bottom, we have data stores. So these range from memcaches to actual databases. This kind of architecture has allowed Twitter to migrate off of the monolith that was Ruby and scale in various functions. We've managed to have multiple teams working on different parts of the application at the same time without stepping on each other's toes. It's also made building product features and prototyping new ideas a bit harder than it used to be, as you can imagine. And during our new hire orientation, we sort of like take people through how they might be able to build a service at Twitter using the infrastructure. So they get to build a thrift service, request storage for the data they're going to be storing, deploy that, and then eventually expose it to the outside world. While it's a great way to onboard engineers because they get to touch all the different parts of the architecture, for the same reasons, it's also a pretty horrible way to prototype a new feature. So we decided, hey, let's try GraphQL. And GraphQL Twitter fits in as both an HTTP service and a thrift service. It uses a range of data sources, of course, thrift and HTTP, as well as data stores. So as I mentioned before, the communication between microservices is already typed, and adding GraphQL here was quite easy because it meant that we had types all the way from the data store through to the client. Okay, at this point, I should probably mention this. We do not allow arbitrary queries to run against our GraphQL in production. Essentially, your queries are submitted and validated and stored in exchange of an ID, which is the blob of letters and numbers you see there, before they can be run by the clients in production. We call them stored operations, but I think they're also known as persisted queries by the community. And this restriction means that attackers can't probe our GraphQL API or run introspection queries against it to find out what data is available. And we built this feature from the start because we knew that once we exposed the new API, we would have people probing at it to find vulnerabilities or do other things. Okay, so that's Twitter's architecture in a nutshell. And next, we're going to look at how we might expose a schema and then look at generating it. Okay, so my main agenda is to get you to look at my tweets. If you go to that URL, you find something that looks like this. It's a series of tweets, each a brave attempt at humor, Game of Thrones, and all of these tweets belong to a user, which is me. And we call all of this a user timeline. User timeline is a series of tweets, right? Pretty straightforward. Okay, so how could we actually model this as in GraphQL? Look at this all at once. So we have the query object, which is GraphQL's root object there. It exposes a user, which you can query by ID and get back a user. The user itself has got a timeline of tweets, and the tweets is an ID and a string. And of course, this is like quite simplified compared to what you're seeing on the right. You don't have the images or the usernames, but it gets the point. So here you might write a query that looks like this. And the thing I wanted to point out here is that GraphQL specifies what data we're getting. It says nothing about how that data is actually going to be fulfilled. All right, and then if you run and operate a GraphQL service, chances are high that you've written some code to specify how you fulfill your data, and you might do this using resolvers. So for the schema we just saw, we might write a resolver that looks like this. And this is sort of like pseudo Scala code. And we're assuming that we're using Sangria, which is Scala's GraphQL framework that we use. So I might write something like this, takes in a context, gives you back a list of tweets, and the context knows things about like where the timeline service lives and how to retrieve that. You get a couple more to get your user and the text string on the tweet. Okay, so resolvers by themselves will only tell you how to fetch the data. We also need to understand sort of like how would you map that onto GraphQL and produce a schema, which is what says what you're fetching. So you might write something that looks like this. It's an object user, and it's got a field, which is timeline. It's typed, and you wire up the resolver that we just saw to actually resolve that field. And this would produce a schema that looks like that when rendered. And then we can do the same for the tweets, fields ID and text rendered like that. And then obviously, we get the query object as well. Okay, now writing resolvers by hand it's okay if your schema doesn't contain a lot of data or it doesn't change very frequently. But it gets complicated fairly quickly and hard to manage when you have many microservices that are running and trying to add data to the same schema. So some of the challenges that might come up from doing this, it's like actually adding data to the API is not that trivial. It's still simpler than when we used REST APIs, but our developers still need to fiddle with the API, think about resolvers and schema code. And resolvers are essentially an easy way for business logic to creep into the API layer because they're just tiny little functions that can do whatever you want them to do. Maybe you start with filtering, some checks, and then eventually you end up with a pile of business logic in there. And this approach also means that we'd need to deploy our GraphQL service every time there's new data. And deploys are important for us because they represent a dependency between teams. And would like to eliminate that whenever we can. It's also harder to enforce good ideas everywhere. Like with this, thinking about things like error handling or access policy or batching your requests. Okay, so here's an idea, quite naturally. What if we didn't write this code? Here our main goal is to help product teams build features really quickly and easily. And we want to make it easy for new data to be added to the schema without developers thinking about um, schema code or manually having to write that. So it sort of like splits the responsibilities between the GraphQL team and the engineers actually writing features. So then one of the jobs for the GraphQL team is to make it trivial to put data in the API. We want to be able to automatically apply good ideas everywhere so that clients can see a consistent view of that. And of course, we don't want business logic in the API. We've worked really hard to make sure that that business logic is living downstream. So we want to make sure that stays the same. And for service owners or data providers, they can then just focus on what they're actually building without concerning themselves with GraphQL or the schema. This also means that they can build features really fast, rapid prototyping, shorten going from development to production. And of course, we're not deploying the service every time there's new data. Okay, so we looked at this code snippet, and we're just sort of going to focus on the user object there. So like looking at this, if you knew you were going to write some sangria code to like expose a field in GraphQL schema, you already know some code you need to write. So the only things you're figuring out is which object does this field belong to and what's the name of the field, how do I resolve it, etc. All right, so if we start from this, now we're going to think of it as a function. It's a function that lives somewhere. Resolvers are that anyway. Just looking at the function definition itself, you can sort of see that we already have enough information that we can use to go and populate the field object. So we could get the name of the field from the function name and the return type. And for how to resolve it, come back to that in a second. But we also need to know where that field is actually going to live. So we might choose to annotate it, and we'll know which object it belongs to. And we might put this in a configuration, and that's how we would resolve it. So we have a config that knows how to resolve fields given a path and the function name, and it just goes and executes that. Okay, so what does this do for us? If we have a new feature service that's been built because we want to build the next cool feature, they can go to this config, define their new feature or the new field, maybe set of features, and that would automatically appear in the user object or wherever it needs to be. So essentially here what we've done is that we've reduced exposing data to the GraphQL schema down to writing a config file, right? And the config, of course, needs to be expressive enough to be able to map between, at the very minimum at least, you need to be able to express the GraphQL type system so you can map between the two. The GraphQL team writes some code, which is a schema generator that knows how to map that, and can take care of things like field naming, conventions, and all that jazz. And the only thing developers need to care about is to understand how the config that they're writing actually corresponds to the GraphQL schema that they're generating. And essentially, this encourages developers to think about the schema first before they can go and write the config, which is a good thing because it encourages what you might call client-first development. To have developers and clients sit down together, think about the schema, and then you go and write a config that exposes that. And this approach also embeds that in the workflow. You have to think of the schema before you can write your config. Okay. So taking that a step further, one of the lessons in computer science is modularity. And wherever possible, we try to make our code modular. So we can shift this config down to live at the service level. And what this means is that each of the services that need to expose data have got a narrow view of the schema. And they only care about the set of features that they're exposing. They don't need to think about where they live, etc. They only get that modular view of the schema. And the GraphQL service would then go and collect up these configs and generate a global schema. So it's sort of like a schema stitching, which we then expose to the clients. And of course, developers also just focus on what they need to do without stepping on other people's code or toes or anything like that. Okay, and then one other thing I should mention is that because we're now expressing GraphQL generation through the config, we only need to upload that to the GraphQL server, which hosts the schema generator. And whenever it detects a change, the config would have been already validated before it's uploaded to make sure that the schema is not breaking. Whenever there's a change, we can just upload that and generate the new schema and begin to run it without deploying the service. Okay, so this is not too far off from what we actually do at Twitter. And the technology we're using to power this is called Strata. I'm going to tell you a little bit about it with regards to how it applies to what we just saw. Now, Strata is not open sourced because it's very tied closely to how Twitter works. But it's still exciting nonetheless. And if you're interested to learn more about it, there's a talk specifically on Strata, which you can find on YouTube. And there's also an academic paper written about it. It's hosted on the Association of Computing Professionals. It's a digital library, and I think it might cost you a few cups of coffee if you want to read the paper. Okay, so Strata. Strata is sort of a federated database, a virtual one, and it brings together multiple data sources so they can be queried and mutated uniformly. And this kind of sounds like GraphQL. Philosophically, Strata and GraphQL are similar. Strata without having many of the benefits, but not specifically for building client applications. Strata has existed at Twitter for longer than GraphQL, and we decided to power GraphQL using this layer. But yeah, so it integrates tightly with our microservices, and because they're all typed, it means we get types all the way through to the client. Okay, so the config that I was just describing in Strata might look something like this. And Strata knows about different data sources. In this example, you see the database. We call this a column. The column represents the configuration, and this one is a database column, so it gets its data source from a database. So we write this in something we call Strata QL. It looks a lot like Scala. It's not Turing complete, and that's on purpose because we're not trying to make it a fully programmable language, just enough for it to be a query language and express the things that we want it to express. And in this case, you see it's got a name, it's a user timeline, database, and we have the key and the value of what this column returns. Right, and engineers can signal that they want the particular column or config file to be included in this GraphQL schema for generation by setting a flag that looks like this. So in this case, this would be a field on the user object. Its name is a timeline. And Strata sort of like bags these up, and we built a schema generator that looks at that and then generates the schema from that. So essentially what this allows us to do then is like engineers have already been using Strata long before GraphQL existed. So what we did is allow them to keep on using the tools that they're already familiar with without complicating them with learning about GraphQL, what it is and what it does. How do I get data to flow through GraphQL, wire it up? They can just continue using that. This could have easily been Scala or your favorite language, as long as it's able to express those types. Okay. So a quick summary of what we've looked at, or what schema generation actually gets us. Firstly, is that adding schema to the GraphQL, adding data to GraphQL is made extremely easy. You only think about a configuration that you express, and that automatically gets you a schema. And we also eliminated the possibility of having business logic in the API layer, which is GraphQL. We've pushed all business logic that could exist down to a config close to the service that's actually delivering that data. And we've reduced API deploys down to a config that we can just upload. It's a file, you can zip it, push it onto the server, and everything is good. All right. Makes building fast and easy. It also, because we're automatically generating the schema code, we can then apply good ideas everywhere. So you could imagine a config as a framework. It could express things like access policies or batching because you have an idea of how your config is laid out, so you know when you can batch things and when you can't. So that's like potential for optimizing there. Now, oh, I have no idea what that is. Okay. So I'd like to finish with this idea, discussion of why we think GraphQL is an exciting technology at Twitter. So in the big picture, we see GraphQL as an enabling technology. This basically means that it can drive radical change of what we can express and do. And obviously recognize this through the huge productivity leaps that are available through using GraphQL and building on top of that to be able to make workflows of engineers even easier. Enabling technologies will often lead to rapid development of subsequent derivative technologies, and tools like GraphQL and everything that Apollo and Relay can do for you are examples of this. And at Twitter, we have various examples of where we've been able to do things that we couldn't before. For example, things like analytics on which clients are using which fields, and how intensively they're using them, and how we can also use GraphQL to sort of deprecate fields and decline their usage in the long term. So then in this way, then GraphQL sort of like expands the idea presented by Stuart Kaufman of the adjacent possible. And this means that GraphQL is radically so different from how we do things or did things, that it opens up new avenues of exploration that were previously closed to us. And the present that we once had of REST APIs, HTTP verbs, or query params is one possible permutation of ways in which clients can fetch data. And there are many others, and we owe it to ourselves and our users to explore those. This doesn't mean that GraphQL does not have any problems. It's not perfect technology. And this goes with all technologies, right? We're making trade-offs all the way down. Okay, that's it from me. And yeah, I can take questions if we have any. Yeah. Going once. Okay, yes.
Sorry, I'm quite new to GraphQL. I've kind of picked up a little bit. What is the main difference between using a GraphQL and a REST API?
Right. That's a good question. Thank you for asking. So essentially with REST APIs are sort of like arranged around verbs or like objects. So you could have, say you wanted to fetch a user, you could have an endpoint that will get you the whole user object. Now GraphQL is arranged around fields and types. So essentially this means that we don't have like a canonical big user object. And as we saw, we're talking about how you would add fields to an object. So this essentially means that you can go and like write a query like SQL, which just specifies exactly what data you want. And you can also, it also solves problems like the N+1 problem where you fetch a user and you get their ID, and then maybe you need to fetch their tweets and then their followers. So you could do that all in one go. Yeah, and then other benefits are like you save data on the client, so you're not sending useless data that the client won't see. Like you're not going to render. And there's many more, but yeah. Yes.
I've got this very cool microphone here.
Right. So since you make it so easy to add new data, isn't there a problem of uncontrollable schema explosion?
Yeah, that's a good question. And this is like something that we're always constantly thinking about it, right? And you might imagine doing things like, okay, well, maybe we should split our schema. But in the long run, there's really no problem with having a massive schema, so to say. Because at the end of the day, like I was mentioning, we're arranging GraphQL in terms of fields and types. And each client, whatever their needs are only concerned with a subset of it. So they don't have to think about the rest of it or any other things. They can just laser focus on what they need, and we're able to give them that. All right, there's one more. Oh, okay. Yes, sorry.
Hi. You mentioned that you have two teams. One is for the GraphQL bit, and the other one is to do the services, right?
No.
No. Okay, never mind. I don't have a question.
Okay. Maybe, I think maybe the confusion might have been from, let's see if I can find it. Maybe these. But I think I know what you mean. Was this the slide you're thinking about? Yeah. Okay. So here I was talking about responsibilities and what different teams need to think about. So here the GraphQL team, essentially for automating the schema, then like those are some of the things that we need to be thinking about. And then the service owners here represent like people running any of the thousands of the microservices. Yeah. Yes.
Okay, based on the schema automation or generating schema based on, sorry, can I generate schema based on configuration to have multiple schemas for one application? Is it possible? Like I have one front end, but for the back end, I have multiple schemas. So by this idea, is it possible to do it based on some configuration?
Yeah. So I think if I understand your question, you said you have one front end and you want to generate multiple schemas from the same configuration.
I have to generate schema based on this configuration. So I have multiple schemas, but I don't have to write the code for the two different schemas. I have to write the code once, but it will generate multiple schemas, but for one front-end application. So is it possible?
Yeah, if I understand. So when you say you have one front end, so essentially this front end can decide which schema it wants to query.
Exactly.
Is that the idea?
Yeah.
Yeah, I think you can, because you're writing the code that's like generating your schema, so you could decide what you do with that.
Mm-hmm.
And I don't know, maybe you might choose to host your schemas on separate GraphQL servers.
Yeah, this is the case. Yeah.
Right.
Mm-hmm.
So you can definitely do that.
I just wanted to write code once, but this code
Right.
will generate different schemas. So yeah. Okay. Thank you.
Yeah. Yeah.
How much of this schema generation tooling is available outside of Twitter? Is it all kind of handwritten, or are there kind of tooling available?
I think if I'm not mistaken, Apollo does some of that. So you can sort of like specify your resolvers and then might be able to convert those into a schema. But yeah. Yeah. But essentially in like a very general sense, it's like the schema code that we write is like very repetitive, right? Like you're always going to be writing an object and then like adding some fields onto that. And in a sense, that just sort of like becomes boilerplate that you need to do.
So my question is, how do you deal with naming conflicts as you increase the number of fields that are going to cover the same source of data?
Right. Yeah.
Without describing the how in the schema.
Right. Yes, that's a good question. And part of like schema generation, so it's like it needs to handle field naming, right? And obviously, if you have someone attempts to expose the same field on the same object that's the same name, of course, the schema generation will explode. And that's actually handled by Sangria, right? Which is the GraphQL framework. So it's the same idea. Even if you didn't generate your schema, you can't add the same field name in the same object. And you can like provide some tooling. Essentially, when engineers are writing a config, they can generate the schema right from the command line. So you can fire up the schema generator, and if there are any errors, you can report those. And yeah.
Cool. I think that's all we have time for. I've got this amazing microphone now, but we're going to have a little 10-minute break now. Thank you very much, Haggai. That was really interesting. And then we'll be over on to Mark. So thank you very much.